Your GraphRAG system just gave a wrong answer. Who do you blame first? The model, the prompt, the embedding model? Hold that. A user asks a simple question. If checkout fails, who is the correct escalation team for EU customers? The agent searches the knowledge graph. It finds checkout service. That node is connected to payments team. A runbook comes back. The model answers with confidence, and it is wrong. The actual EU escalation policy is in the graph. The relationship from payments team to that policy is missing. Here is the part that should bother you. The trace is green, no database error. The model call succeeded. Latency is normal, no exception in the logs. Everything worked. The evidence path was incomplete. This is not only a model failure. This is an observability failure. One clarification before we instrument anything. Span links do not magically detect a semantic gap. A span link is just a causal tie between two operations that may not be parent and child. To see the gap, you still record the retrieval. Selected entity, traversed edge, candidate count, what reached the prompt, what was dropped, and whether the claim maps to evidence. Links give you the map. Attributes, events, and evaluations give you the failure signal. Traditional RAG pulls chunks. GraphRAG pulls relationships. That is why one missing hop can fail you even when every retrieved document looks relevant. Start node correct, first hop correct, full path still incomplete. The model will not usually say it cannot answer. It completes the pattern from internal knowledge. Fluent, plausible, wrong. Do not call that random hallucination. Call it a plausible answer from an incomplete evidence path. Normal application monitoring asks, did the graph query succeed? Did the model endpoint respond? Was latency inside SLO? Did tokens spike? Did anything throw? Those questions matter. They do not answer this one. Was the evidence path the agent used complete? Logs can show retrieved node 123, retrieved document a BC, generated answer successfully. They will not tell you how those relate, which evidence made the prompt, which graph branch was discarded, did a missing edge trigger a fallback. Without that causal structure, logs give you events. They do not give you the reasoning path. If the pipeline is a simple chain, parent-child spans are enough. Production agents are rarely that linear. Vector search, graph traversal, cache, and an async re-ranker can all fan into one context builder. Force that into a fake tree and you hide causality. Span links exist for this. Asynchronous call stays parent-child. Async, fan-in, cache, or cross-trace evidence gets a link. Do not emit a link on every graph hop. That is telemetry noise. Here is a practical shape. Top-level span, invoke agent. Under it, resolve entities, graph retrieval, vector retrieval, assemble context, generate answer. On traversal, keep a few attributes that earn trust. Hop index, candidate count, path complete, termination reason, and whether evidence made the prompt. Use stable IDs, not raw customer values. Then link assemble context to the spans that actually produced evidence. Now you can see provenance for the final prompt. There is no single context gap metric. Start with the one that matches this incident. You reached payments team. Expected edge escalates through. Candidate count 0, record termination reason. No matching edge. Fire context gap detected, coverage 2 of 3. Then you can say the traversal stopped after hop 2, and the generator made a claim with no linked evidence. That is actionable. The other fractures, ambiguous entities, dropped prompt evidence, ungrounded claims use the same pattern. Count it, do not hide it. This is the end-to-end trace for that EU escalation query. Not a vendor screenshot from someone else's cluster. A real OpenTelemetry payload for this incident. The same shape you would export to Jaeger or Grafana. Parent span invoke agent. Status OK. Child span graph retrieval, also OK. Look at the attributes. Hop index 2. Expected edge escalates through. Candidate count 0. path complete false, termination reason no matching edge. Then an event, context gap detected, coverage 2 of 3, fallback abstain. Assemble context does not pretend this hop is its child. It uses a span link back to the graph retrieval span, with evidence channel graph, selected true, path 17. The waterfall is green, the payload is not empty, that is the whole point. You do not need a red span status to see where the evidence path stopped. You detected the gap. Do not auto-heal the graph. Automatically adding a relationship can turn one hallucination into permanent knowledge. Safer loop. First, retry retrieval, alternate entry node, vector fallback, different edge type, or a safe hop limit. Second, change the response policy. If evidence is incomplete, do not generate a confident answer. Say you found the service owner, but could not verify the regional escalation policy. Third, create a repair candidate. Missing edge type. Affected queries, source documents that may contain the relationship, failure frequency, business impact. Fourth, validate before mutation. Offline evaluation, source verification, domain owner approval. Then update or reindex. That is not fully automatic self-healing. It is an evidence-aware recovery loop. That framing is trustworthy. Once the spans exist, stop staring at one trace. Aggregate gap rate, path coverage, and unsupported claims. Do not use high cardinality node IDs as metric labels. Keep those on span attributes. Bound metrics to node type, edge type, failure reason, environment, retriever version. Then a quality drop can correlate with a graph ingest, not only a model bump. That is GraphRAG observability. Watching the model output is not enough. The wrong answer is often the last symptom. The break started earlier. Entity resolution, graph traversal, a missing relationship, re-ranking, token budget trimming, or context assembly. You just saw that path on one trace. Span status OK. Gap in the attributes and the event. Span links for the fan-in. If this was useful, please subscribe. It is the simplest way to get the next agent black box lab when a green board hides the real break. And if you have a minute, comment the hop where your evidence path actually stopped. That question is how you observe the knowledge system, not only the model output. Thank you for watching.